Let's go ahead and take a look at what it looks like to compare two proportions, right? We have sample proportions. We're going to do what's called a two proportion Z interval or Z test, depending upon the type of question we want to answer. Here are some survey data, Asian American voter survey data, and they were asked a question, right? Filipinos and Japanese. And you can see in the graph here, percent of Asian Americans who posted about politics and social media. And you can compare. The blue is no, the pink is yes, and I don't know or don't know is you can't see, it's not accounted for. But you could compare and contrast them. And that's what we're essentially doing when we're going to do our hypothesis test or test for difference or looking at a confidence interval, right? And so what do you see? They're kind of close. Filipino a little bit more in the pink of yes, Japanese a little bit more in the blue, right? Versus another question like this, asking them what percent discuss politics, right? And then you can see, is there a real difference? There's a slight difference, but is it enough, right? And that's why we have to run a hypothesis test or do a confidence interval to actually determine if statistically there is a difference, right? Even though the actual numbers are different, but that's for a sample, right? A small sample. And so to do something like that, we would do a confidence interval to compare this. Estimate the difference in percentage. So I'm actually trying to come up with a value. You have your proportions, right? We're going to be, our parameter, step one, we're going to be checking the difference. What is the difference between the proportion of Japanese and Filipino? This is a two proportion Z interval. And again, this is because we're saying estimate. I want a value. Here's the sample data, always important to consider. And you can see we do in that fifth step where we have to check to see if the success and failures are big enough, which we'll look at later, but you can see that calculation there. And then you get an upper bound and lower bound. Now, if we do this calculation by hand, it's really tedious and easy for mistakes if you're doing it by hand. So you would use the ARTIS stat. You would get into the ARTIS stat. You're going to compare the two proportions, which you also have an example in. Homework of this type of work, and you can see where the values come up: negative 2.3, which is 23%, to 8% in this case. And so what that means is we're 95% confident that the proportion of Filipinos who post about social media is greater than Japanese by 8.1 to 23.3%. Again, those values come from the confidence interval, and you go ahead and use the ARTIS stat to get that. We're not doing the hand calculations. Now, when we do that, again, you use the ARTIS stat to get those numbers. And here's what it looks like in the ARTIS stat. You have the two proportions, compare two proportions. We're doing a confidence interval. You can choose the interval. Now, the only thing is your choices you have are textbook, which we don't do, number of successes, or if you had the actual data. And so notice I have a 41. That number was not in or your notes. That comes from 18%, right, for the Japanese. 18% of 226, the sample size is 41. And then we had a value of 34%, and you saw that calculation. 34% of 263 is 89. And then you have that. Then you get the confidence interval, right? Again, this is an estimate for what we think the difference is between Japanese and Filipinos, because the data we had was from a sample. So using that same idea, we go to the two proportion test, and then this other question that we had, which was around whether you actually discuss politics with family and friends, what proportion. So the same idea, we're checking to see, is there evidence in a difference in behavior? So that would be a not equals, right? It'll be a not equals. Now notice you could write it in either form, right? I have it in green up on top or blue here. Those are equivalent forms. But the ARTIS stat does use the difference representation. Two proportion Z test, or alpha is 0.05. We have sample data here. So we're checking to see, is there a difference between those? Again, you'd go to the same place. Instead of confidence interval, you do a significance test, and then you would enter in the data as is, the way we had. and then you would end up with a z-test statistic, p-value, and then we have the same conclusions. Now hopefully you're starting to see the same stuff, right? Since the p-value is less than alpha, we reject the null hypothesis. We have sufficient evidence to conclude there is a difference in behavior between the two groups. Again, trying to see if this would be true for all Japanese and Filipinos, right, who fit the population of interest, because we only have sample data. And this looks like to be enough to see there is a difference. It's a big enough gap for us to make a conclusion that the gap exists for the population also. So that's how you would do it. That's how you run a test. Again, you would use ARDA-STAT to calculate these values here.